Good morning, everyone, and welcome. My name is Roger Snyder, and I'm the Vice President of Marketing at 280 Group. Thank you so much for joining us this morning, as today we'll be discussing machine learning and whether it can help add value to benefit your customers. Bastiane, if you would mind advancing the slides for me. All right, next slide. I am joined today by Bastiane Huang, who is product at Osaro. Bastiane has extensive experience in product management and business development. She currently works at Osaro, a San Francisco-based startup that builds machine learning software for robotic vision and control, and works with the Amazon Alexa group. She also worked with Harvard's Future of Work initiative and writes about artificial intelligence-enabled robotics, machine learning, and product management for robotics, Business Review, and Harvard Business Review. So really excited to have your expertise and your knowledge with us today, Bastiane. Thank you for joining and being with us today.
Thank you, Roger. It's my pleasure to be here.
Great. So let's go over a few housekeeping items before we get into the meat of our presentation. After this webinar, you can continue to stay engaged with our product management community. And these days, it's more important than ever to get connected with peers and have some great conversations. So join our LinkedIn group. I will put the link into the chat box for you. And join this community because we have great conversations. You'll also be able to stay on top of all of the exciting new assets and free resources that we provide to our community through our LinkedIn group. All right, let's talk a little bit about 280 Group and some of the logistics here. So during the webinar, we would love for you to engage with us. We would love to hear your questions. So use the questions box, it's outlined here, and type your questions in there. We're gonna have time for Q&A at the end of the webinar. So we need your questions to make that a nice interactive time for us to learn a little bit more about what you really want to learn about this exciting topic, and to pick Bastiane's brain because she is quite knowledgeable. I've read several of her articles and I learned a lot. Even though I have a degree in computer science, it's been a while and I picked up a lot reading her materials. So I'd love to get some questions from you so that we can have a great conversation. Now, our most popular question when we run these webinars is, can I watch this webinar later? And the answer is absolutely yes. Every attendee will receive a link in our follow-up email that will allow you to view the webinar recording after it has ended. All right, so before I hand this webinar over to Bastiane, let's go over a little bit about 280 Group. So Bastiane, if you can advance the slide there, please. At 280 Group, our mission is to empower product managers to do great product management and become product leaders so that ultimately you have the knowledge and tools to deliver products that matter. That's what really matters to us, is helping you deliver products that matter. So if you need help, your next slide, if you need help improving your product management or product marketing skills, you can see we provide a variety of different services. So I encourage you to check us out at 280group.com. All right, one more slide. Yes, thank you. So just this week, we launched a whole new course. It's called Digital Product Management. And this course focuses on the key skills and the tools needed by product managers to quickly and iteratively discover, design, deliver, and grow digital products, and be able to do that with confidence. This is an exciting area. There's a number of folks now who are adding a digital component to a product. For example, if you have a hot tub and you want to have an app that allows you to then turn that hot tub on as you're coming home from work so it's nice and warm when you get home, that's a digital product being added to an existing product. And many product managers aren't familiar with the pace of innovation required to run a digital product. If you're a hot tub product manager and you now need to get into the digital space, this is going to be a course to help you. It'll also help folks in IT organizations and even new product managers who are just getting their feet wet in the digital space. So check out this course. I will paste a link to this course also into the chat box so you can check it out. All right, and now let's move to the last slide here. We're excited to continue to offer you this leadership webinar series, especially during this time when it's been very difficult to innovate, when all of us have been separated. And we've spoken with various peers to uncover your priorities, and we love to cover various topics for you. And so today, that's why we're bringing you this special topic on machine learning. It was a topic that polled very well in terms of interest, and it falls into our theme of implications of change. So if you animate, you can see a little diamond there. And again, ultimately, our goal with this series is to help enable you and your teams to build better products. So that's a little bit about us. And now I want to get to the exciting stuff. I want to let Bastian take over. So Bastian, oh, sorry, one more slide. We always love to know who's in our audience. And today, nearly 50% of our audience is product managers and product marketing managers, but we have a good spattering of over 20% of vice presidents and directors of product management, a nice representation of product owners as well, and a big group of other folks, probably people who are interested in product management or just interested in machine learning from a product management perspective. All right, and with that now, I will turn it over to you, Bastian. Take it away.
Thank you so much, Roger. Hey, everybody. Good morning. My name is Bastian. And today I want to just share a little bit of my experiences managing machine learning products. And before we start, one thing to know is that this is still a very nascent area. It's still evolving. And there's really no one way of doing things. So throughout this presentation, it'd be great if you can also think about the best way to apply machine learning to your products. Maybe you would decide that it's not the best time to apply machine learning to your products just yet. What I want to do here is really just to encourage more discussions. That's why I also write articles and host events for machine learning product managers to exchange thoughts from time to time. Love to get your feedback. So if you would like to connect, you can visit this link here, bastian.substack.com, or go to my Medium. Yeah, so here's the agenda for today. I will do a brief introduction about myself, what kind of machine learning products I've worked on as a background, some context for you. Then I will go through some of the basics about machine learning. What is machine learning? Why is it so important? What is the difference between artificial intelligence and machine learning? Then we'll get to managing machine learning products. Why is it more challenging, more difficult than managing other type of software products? How is it different? What are some of the best practice and key principles? Yeah, so a little bit more about myself. So I studied computer science in my undergrad. Over the past few years, I've been working on mostly product and business development in tech and manufacturing industry. So first work on a video recognition software that does facial recognition, people counting, gender identification, as well as license plate recognition. Then I joined Amazon Alexa as a senior product manager, work on Alexa Engine, which is the core platform of Alexa. I also work with Harvard Business School's Managing Future of Work initiative, write articles and cases about artificial intelligence, automation, and their impact on our future of work. And now I'm with Osaro. So I want to give you a little bit of background about what Osaro does, just because I will be using Osaro's machine learning products as examples throughout the whole presentation. So broadly speaking, Osaro works on deep learning and reinforcement learning, and we specialize in computer vision, or more specifically, robotic vision and robotic control. So as you can see from this slide, essentially our system take images from cameras and use those images to predict the optimal grass poses for a wide range of different items. So unlike traditional machine vision, we don't need prior information like cat model or registration of the items. We just use the image to predict optimal pick places and also orientation of the objects. So with this information, our customers who are normally warehouse owners or manufacturers, they can then use this information to automate things like machine tending, product packaging, and kitting. So this sounds very specialized in robotics, but the fundamental machine learning architecture technology is actually very similar to those kind of computer vision, deep learning, image recognition technology that you've seen in your daily life.
So Bastian, if I understand what this is about, if you stay on that slide, second.
Sure.
Those little blue circles are not actually on those objects, right? That's your algorithms identifying this is the right place to grasp each of these items in the bin. Is that right?
Exactly. Yeah, and it's also different from traditional robotic programming where engineers program a robot so they know, oh, I need to go after the center of the bottles. This is all self-learned by the machine. So the machine would try to pick by itself. If it fails, it will try a different way. If it's a C, it will continue to pick from this same position.
Yeah, that's amazing because now you have a bin with a mixed size and shapes of bottles, and the algorithms allow the robot to react in real time to new circumstances, new environments, new types of bottles, right?
Yeah, yeah. So that's actually what we're about to get to. The main difference that machine learning brings is really to allow a machine to be able to learn by itself and adapt to changes in the environment.
Great. All right, so let's find out a little bit more about our audience and launch this poll. I'm going to launch it right now, and then Bastian, you can kind of read the question and answer, folks.
Yeah, so we'd love to get to know you more. How much do you know about machine learning? One, I have extensive experience with machine learning as a product manager. The second one, I have some experience with machine learning as a product manager. Or I have some experience with machine learning, but not as a product manager. I'm a product manager curious about adding machine learning to my product, or I'm not a product manager and just learning about machine learning now.
Great. Yeah. So this helps us kind of get a sense of both how well does the audience know machine learning and what kind of perspective are they coming from? Are they coming at this as a product manager, or maybe they're coming at it from a more general perspective?
Mm-hmm.
Poll open for a few more seconds. We've got quite a few people who have already voted. Yeah, actually, I'm thinking this is kind of what we were suspecting, and you and I talked before the webinar on what audience we were going to see, but I'll give people a chance, another second or two to vote just to be sure. But I'm thinking we're seeing a pretty obvious trend here.
Mm-hmm.
All right, give you one more second. Let's close the poll, and now I'll share the results. So the 56% of the audience said that they are a product manager who's curious about adding machine learning to their product. And that's what you and I had kind of suspected that might be the audience. 19% said they have some experience with machine learning, but not as a product manager. So that's interesting. So they come from other disciplines. 14%, I'm not a product manager and just learning about machine learning now. 11%, I have some experience with machine learning as a product manager, and 1%, I have extensive experience. So the sweet spot here is I'm a product manager curious about adding machine learning to my product. So those are the folks that we should try to appeal to today as we're talking about this.
Cool. Yeah, that's helpful.
Yeah.
Yeah. So let's get into machine learning and talk about why is it important. So as Roger and I kind of already alluded to, machine learning, the key difference is that it enables a move away from having to manually program the machine to true automation, to true autonomy. That means that the machine can now self-learn a lot of different things it couldn't before. And machines can make predictions and improve insights based on patterns they identify in data without human explicitly telling them what to do. That's why machine learning is particularly useful for challenging items that are difficult for people to explain to machines. And it also means that the machine learning can make your products more personalized, more automated, or even more precise.
Mm-hmm.
So here I have an example. I borrowed the definition for self-driving car here. So as you can see, if you're familiar with autonomous car, you know that there are actually 6 levels from level 0, which is essentially no automation, all the way up to level 5, full autonomy. And right now, most of the system we've seen, like for example, robots and in factories, we see a lot of automation going on in factories and warehouses. Those are actually either level 1 or level 2. So level 1 is mostly like driver assistance, so humans still take control with just a little bit assistance from the system. We call it single automated operation. So someone, mostly engineers, need to still go in and program a robot, and the robot would just the robot or machine would just repeat the same process over and over again without taking any input from the environment. When you get to level 2 partial automation, the machines do get sensor input from the environment. So for example, you can attach a machine vision camera to a robot arm, so the robot can now react to some changes in the environment. But these changes need to be pre-programmed. So it cannot be something that's totally new or surprises, otherwise the robot still cannot respond to it. But when you get to level 3 and level 4, right now, because we have deep learning, reinforcement learning, so we actually started to see level 3 and level 4 autonomous systems, conditional and high autonomy. In this case, you don't really need humans to go in and actually program a robot. The robot will be able to learn to recognize a wide range of different items and learn to react to it. So that's the benefit of machine learning.
So a question or two here, like many cars now are starting to have the ability to like self-park, right? And is that self-parking kind of a level 2, or is that a level 3 level of autonomy?
So I would say it's probably almost level 3 because the difference between level 3 and level 4 is that level 3 only works in a very limited scenario.
Right.
And level 4 is like high autonomy across a wide range of different scenarios. So in that situation, it only works when you are trying to park, and sometimes it even fails. But it's still autonomous. It doesn't really require people to do anything.
Right. No, it's a pretty amazing technology. And then I assume like the Tesla self-driving is more like a level 4, right?
Yeah. Well, yeah. I think but like it still requires driver to actually take over from time to time. So I wouldn't say it's like full autonomy, but I think it's pretty high autonomy and in most cases.
That makes sense. Thank you.
No problem. So let's talk about why machine learning is important. So the adoption of machine learning has been rapidly advancing across various business sectors. Nearly half of the companies have incorporated one or more artificial intelligence capabilities in their process, and another 30% are piloting AI projects, according to McKinsey's recent survey. So if we look at this chart provided by McKinsey, you can see that a lot of different industries and functions, we can see that machine learning, there's potential to actually use AI and machine learning. And this is another chart by McKinsey to basically show that they rank different industries by their potential to be automated. And they identify some key tasks that they consider would be easy to be automated in the near future. For example, like predictable physical work, processing data, or collecting data. And the top 3 industries that have the highest automation potential is accommodation and food, manufacturing, transportation, and warehousing.
Yeah, I was surprised actually when you showed us this chart, when you and I were looking at it before, of just how much opportunity there is to automate in some of these areas, particularly like food services and accommodations. So that's an amazing opportunity that I hadn't thought about before.
Yeah, it's interesting because before when we thought about automation, we only thought about those kind of things that we can repeatedly doing, so we can program a robot to do that. But now, because if machine learning machines can actually react to certain like level of changes and can learn a range of different things, so we'll actually open up more opportunities and more tasks that's possible to be automated.
Yeah, it's amazing.
Yeah. So we can also see that from exploding AI funding over the past few years. As you can see here, a lot of venture financing and a lot more AI companies being founded in the past few years. And a lot of big companies like Google, Apple, Microsoft, they have each acquired at least more than 10 AI startups. And recently, traditional incumbents also slowly started to react. It's not listed here, but for example, Nike acquired AI-powered inventory management startup, Select, and McDonald's also acquired a personalization platform called Dynamic Yields. So you can really see that AI is entering every different industry.
Yeah, that's amazing.
Yeah, so we can also see that trying to draw parallel and compare the adoption to AI to adoption of mobile over the past few decades. So if we look back to history, we can see that mobile really started to grow after 2008 when Apple launched their App Store, and then we start to see a lot more app companies to go IPO, like for example, Eventbrite, Tinder, etc. And in 2017, Google actually announced that they're going to switch from a mobile-first strategy to AI-first strategy. So we expect to see a lot more AI companies go IPO, a lot more AI companies being founded in the near future.
Yeah, this is quite a shift, right? This is now more important than mobile, when I still feel like mobile still hasn't completely, I mean, lots of people have smartphones, but I still don't think people leverage the capability of having such a powerful computer in your pocket as much as it could possibly be done. So if that trend's not done yet, but AI is overtaking it, that's pretty impressive.
Yeah, I think it definitely takes time, and we are still in the very early stage of machine learning. But it's already not hard to see why machine learning is expected to have even more transformative than impact than mobile technology. However, the transition to machine learning could also be more challenging and be harder than transition to mobile. And that's what we were talking about today. But before we talk about why that's the case, let's think about what kind of products we're actually working on. So what kind of machine learning products are you actually building or thinking about? Are you working on enterprise products, or are you working on consumer products? So my experience is working on consumer machine learning products like smart speakers like Alexa usually have a stronger social components with its users. So user experience is really, really important and plays a much more critical role in designing consumer machine learning products. So in this case, it is from my experience, machine learning tends to become an enabler for better user experience and for better user interaction. So for example, we use natural language processing to improve the interaction. So Alexa and its user can have more natural interaction. So when I work on Alexa, I actually spend a lot of time working with our user experience and UI team to optimize user experience. And we go through what we call voice user interface live online and trying to make sure that we deliver the best experience. And it's very different experience compared to my experience at Osaro, which is more, it's B2B and more industrial products. It's really more about like the accuracy, reliability, robustness that our machine learning model can offer, because the key is really to be able to predict the optimal pick points so that users can really automate their processes. And our customers, they put less emphasis on the user experience or user interface itself. So that's just something for you to think about when you have limited resources and you want to consider like which area you want to focus on. Like for example, at SAR, we have a much bigger machine learning team and a small design team. That's because our customers focus on the performance of the machine learning models.
Right.
And another thing to think about is, are you building a machine learning product, or are you just applying machine learning to your products? If the core value of your products comes from machine learning models, like the case of Osaro, then you're likely building a machine learning product. On the other hand, if machine learning is used to enhance user experience or performance of your products or do personalization, customization or optimize your recommendation, then you're more likely applying machine learning to your products.
Right.
And I think that's the case for most of the companies and probably most of you here as well. In this case, it's more important to just understand the input and output of the model, but not the actual technical details like architecture of the machine learning model, or whether the machine learning models are based on like convolutional neural network or RCNN. So for example, you just need to know if the model takes in demographic data of users and trying to predict their monthly spending on the platform. So you just need to know the input and output of the machine learning model. And a lot of companies also leverage existing solutions. They don't really need to reinvent the wheel and build a model from scratch. And a lot of off-the-shelf solution in the market as well. So the organization structure would also tend to be different. So for companies building machine learning models, machine learning products, or larger organizations with heavy investments in machine learning like Facebook and Google, it's common that they hire a lot of machine learning researchers, scientists, PhDs, and pair them with machine learning engineers to develop products. But for companies applying machine learning to their products or smaller companies, it's usually better to hire multidisciplinary machine learning engineers and or train your software engineer to learn machine learning instead of hiring machine learning researchers or scientists.
Interesting.
So as a product manager, we need to know what can and cannot be done with machine learning and when we should and should not use machine learning. So let's start with some machine learning basics. So there are 3 main types of machine learning. As you may already know, the main type is called supervised learning. That's actually most common. Probably 80–90% of the machine learning products you see out there are supervised learning. So it's called supervised because it's supervised by humans that learn from label data, and human labels those data and then predict outcomes. I'll show you an example of supervised learning and deep learning in the next slide. So unsupervised learning, as it's suggested from its name, it doesn't really need any label data and supervision from humans. So it just identifies patterns without any label data. But we can use that for clustering, for anomaly detection, for association. And reinforcement learning, I will also talk more about this. Essentially, it learns as algorithm gets more feedback from the environment. So you reinforce the algorithm with positive feedback or negative feedback. And it's usually used in control domains like robotics or self-driving cars. So
supervised learning is like you feed the algorithms thousands of pictures of cats, basically, right? And they're labeled cats. So that's how the computer learns that, okay, I know what a cat looks like now because you fed me these thousands of images of cats, right?
Yeah, exactly. So, and then you have to label the images as cats or dogs.
Right.
In the case of unsupervised learning, you don't really label the images. So like in this case, most of the deep learning are actually supervised learning. So like Roger already mentioned, you build a deep neural network and the network takes images, label images as input. Then in each layer, it will transform the input into a slightly more abstract and composite representation. And eventually, it learns to recognize a cat, a dog, or human. But when it comes to control domain, we don't really need label images. So just imagine that you are learning how to walk as a human, right? So we don't really need to see label images of joint angles. We just try to walk, and if we fail, we know we need to adjust the way we walk. So it's very similar to robots and machines. In this case, you have an agent, which is usually a machine or a robot. It takes an action based on its current policy. A policy just a way of acting. And then based on the actions it takes, it receives a feedback or reward from the environment. It then moves on to the next state and learn from the reward, adjust itself, and repeat this process until it maximizes a longer term return. So that's how reinforcement learning works.
Okay,
You
so
can
that's
also,
good.
yeah, you can also combine deep learning and reinforcement learning. So you have a machine that's able to recognize different items and then react to it. That's kind of what we do at Osaro.
Right,
So
right.
I can show you a brief example. Oops. Let me just play. Oops, it doesn't play.
Well,
okay, fine.
Yeah. Let's talk about that last thing you were just talking about, which was combining techniques, right? So if you're teaching a robot how to walk, you also can train the robot using maybe supervised learning of here's 100 examples or 1,000 examples of staircases. And then once it knows how to identify a staircase, it can then apply what it's learned about walking up or down stairs to that particular circumstance. Is that an example of kind of combining techniques?
I think what you described sounds more like what we call imitation learning or deep learning if it's like looking at images. If I want to combine deep learning and reinforcement learning, then what I do would be like in this case, in this picture, I would be able to use deep learning to allow the robots to recognize tomato versus chicken nugget, and then where to pick the chicken nugget, and then use reinforcement learning to train the robot to use different actions or different trajectories to pick those items.
Okay. Yeah.
Yeah. Yeah, so of course, like you can also combine a lot of other machine learning techniques like fusion learning, transfer learning, or imitation learning to also shorten the learning process. But those are the main areas of machine learning that we often see. So like, for example, we see a lot of image classification examples using deep learning. We also see a lot of natural language processing, like the case with chatbots, voice assistants, or just pre-processing data. So like this picture is from Facebook's research team. So they use deep learning to do image classification so that they can automatically generate audio caption or hashtags from the photos.
Yeah, this is an amazing example. I thought that was pretty cool, but I think your point of the last bullet is probably where machine learning is touching people the most, is with these automated assistants, with the voice assistants, right? So every time you're using Alexa, every time you're using Siri, you are taking advantage of something that's been educated with machine learning.
Yeah, and that's actually also why machine learning products are so challenging. So as we talk about before machine learning, we really need to go through a lot of different steps, and then if we're trying to teach the machine to recognize cats and dogs, we need to come up with rules like maybe like a cat has 2 ears, 4 legs, but how is that different from a dog? So we really need to go through a lot of different steps to actually teach a machine. And now with machine learning, it's much easier because we don't really need to come up with explicit rules. We just need to define the problem, prepare the data, label the images, and train models with label images, and iterate until you have a model that delivers your desired results. But because of this iterative nature, because machine learning takes a lot more experiments, it also involves more uncertainties. Many machine learning algorithms lack transparency. It acts like a black box that takes input and outputs prediction. So it's really hard to take full control of machine learning model. And it's also hard to explain to your users or other stakeholders how exactly machine learning works and get buy-ins from your users and stakeholders. And also because it's probabilistic, it's not deterministic. So you also need to manage the expectation from your users because it's probably not going to be 100% accurate. So in a lot of critical domains like healthcare, where accountability and transparency are extremely important. It's really challenging to ensure alignment between machine learning work and customer problems without a clear understanding of how an algorithm actually works.
Good point.
Yeah, and also because it's a highly iterative process. Oftentimes even machine learning scientists have to test a few approaches before choosing a satisfying one. And that's why it's often more difficult to define milestones and estimate a timeline for machine learning products, just due to the nature of machine learning products. It's critical for machine learning product managers to clearly define requirements, metrics, and ensure a team it actually frequently tests models against the desired metrics.
Right. It also sounds like then the product manager has to have some patience with these, when you're trying to build a schedule, for example, and understanding that this is going to be something to be done in chunks of time rather than expect that you can build a roadmap and just drive to a product launch in a predictable fashion.
Yeah, definitely need to give the team more flexibility and room to explore, but also guide the team to focus on customer problem and not just focusing on like researching problems or the most advanced machine learning models.
Right. Yeah, it's a balancing act, definitely.
Yeah, so we can really see that building machine learning model is not just a technical challenge, it's also a structural challenge. It needs a totally different mindset. It needs to be embracing experiments, you need to be more data driven, and you need to be more open to uncertainties. And it's not just for the product managers, it's true for the entire organization.
It's a team effort for sure.
Yeah. Another point I want to add is that machine learning is still very new and still evolving. If we look at the history of software engineering, it first appeared in 1965, which is basically 15 years after programming languages started to appear. And almost 20 years later, the Software Engineering Institute was established to manage software engineering process. And today, we have generally accepted best practice for software engineering. But machine learning, on the other hand, only started to flourish as a separate field in the 1990s. And deep learning as a subset of machine learning only started to become more popular and widely discussed in 2012 after the rise of AlexNet. So compared to software engineering, machine learning is still in its infancy. That's why we don't really see a lot of industry standards, metrics, infrastructures, tools. Everybody's still exploring the best practice and killer application use cases for machine learning. So it's really exciting, but it also means that it's going to be more challenging during this early stage of machine learning. We still need to try to figure out what is the best way of managing machine learning products.
Yeah, this slide gave me a great perspective. I mean, you're right, we can go back to 1965 in terms of software engineering, but I mean, the agile methodology has only been around 20 years, and yet there are still tons of companies that have not adopted the agile methodology in their software development. So if it's taking 20 years for what's considered a pretty standard approach to software development to be adopted, machine learning is even further behind there. That's amazing.
Yeah.
So yeah, we're at the dawn of this new era. This is pretty awesome.
Yeah, that's very true. Another thing is that even if you're building a machine learning products, it's really the case that you will only involve machine learning. It's often interdisciplinary and involves not only models, but also software engineering, backend, infrastructure, data analytics, UX, UI, and sometimes hardware too. So as a product manager, the challenge is to manage cross-functional team and deal with interdependencies and potential clashes among teams. Because machine learning is really different from other disciplines, as we explained before. So it becomes even more complex if you're building machine learning products, and then you have to coordinate with different teams.
Right.
Yeah. So some of other like challenges, like for example, the sensors could be really noisy, and you also need to consider like integration, connectivity issue. This is also true for self-driving cars, where you have a lot of different inputs from a lot of different sensors, and then you need to figure out how to clean the data, organize the data. 80% of machine learning projects is actually just organizing, cleaning the data. Only 20% is about actually building the machine learning model and training the machine learning models.
Right, yeah, and we're going to cover that a little bit more. In fact, there's already been a couple of questions from the audience about this whole data collection aspect, right? So we're going to cover that next, which is great. But let's pause for a moment and ask our group a little bit, now that they've learned a little bit, why don't you read the question out as we're gathering the information?
Sure. Now that you know a little about machine learning, do you think it could add value to your products? Looks like it could add significant value. It might add value to my product. Don't know yet. I don't think it would add value, or definitely not a good fit for my product.
Right, so good range of questions here. I'm going to let the poll stay open for a moment. The data collection aspects that, I mean, I remember driving around Silicon Valley and seeing so many of the automated cars driving around with the amazing sensor packages on them, right? And that's still going on because you just have a massive amount of data to be able to, you need a massive amount of data to be able to handle the difficulties and the uncertainties of real life traffic, right?
Yeah. And I think the trickiest part is what kind of data you actually need. Like for example, the data Tesla collected and the data Waymo or Cruise collected is really different. It's not like you just need some people to drive on the street, and that those kind of data will be suitable for their models. It could, you need to use like very specific sensors like LiDAR, so it's not just a normal car. You have to drive a very specific car with the specialized sensors. So really, it's critical to define what kind of data you actually need, and then start to build your data pipeline.
Right. All right, I'm going to close the poll and let's see what the results look like. So share the results. So this is exciting, actually. So the largest category was the top one. 42% of our audience said it looks like it could add significant value to their product. So that's very encouraging. And then the next largest is 36% saying it might add value to my product. And 18% say they don't know yet, with small percentages for the other two answers. But you know, we've got 78% in the top two saying, yeah, this looks like it could be valuable. So that's exciting. So let's learn more.
Yeah, let's get to managing machine learning products and. Yeah. So like we already talked about, machine learning is really a tool, and it's one of the tools. So we don't really need to build a machine learning model if the problem we're solving don't really require machine learning. But if we do think it fits with our requirements, with customers' problems, the first step is really start by identifying the problem and define the problem well. So what kind of problem is best suited for machine learning to solve? As I mentioned here, machine learning is best suited for making decisions or predictions. There are like a lot of different machine learning applications, and we can actually categorize machine learning applications into three main types. The first one is detection and inspection. You probably see this is probably in most common use cases. I see a lot of like image classification, computer vision, essentially help users to identify where defects or anomalies are. So for example, you can do fraud detection, banking or insurance, or you can detect a defect or in the production line. This all falls into this first category of detection and inspection. Second category is called pattern recognition. So essentially help users to sift through a massive amounts of data. So for example, like a lot of companies or social network platforms, they do more personalized recommendations. So for example, when you go to Facebook, you see a timeline that's actually recommended for you and different people will actually see different timeline. So those are a recommendation. You can also use machine learning to do ranking, personalization, classification. In industrial setting, you can use that for predictive maintenance to predict when you need maintenance for your systems. And you can also use pattern recognition to enable more natural interaction with your users, like the natural language processing for smart speakers or chatbots that we just talked about.
Right.
And the last category, high dimension cognition, essentially also help users to sift through massive amounts of data. But in this case, it's high dimensional sensory data. So the examples we already talked about are AI-enabled robotics or self-driving cars.
Right, right. And those different kinds of data that you were talking about, the need to gather.
Yeah. And sometimes you should probably avoid using machine learning if, for example, what you're solving, what the problem you're solving can be addressed with simple rules, or the solution you're building doesn't really need to adapt to new data. It's always going to be using the same data, or sometimes it's the case that you just can't access the data you need for training machine learning models, or you can you can get to proprietary data. So that means that you probably don't have competitive advantage against your competitors in terms of data pipeline. Or sometimes if your data product requires high accuracy or full transparency, like in the case in healthcare, a lot of times you need to comply with regulation, you need to have full transparency, then it's more tricky to use machine learning in that case.
Right. So these are good cautions for product managers to think about.
Yeah, and then and we talk about like the fact that we, as a product manager in machine learning products, we need to give the team more flexibility, more time to explore different things. But how do we help the team stay focused and focus on the right problems we wanted to solve? I think there are actually 3 things as a product manager can do. The first thing is to define an objective function. So what is the desired outcome that your model is trying to predict? You're trying to identify patterns in data. Are there any ground truths that you can compare your outcomes or your models to? So for example, if you design a model to predict the weather, you can validate the performance of the data by comparing forecast to actual weather data. So you can use that as a benchmark. That's relevant to the second thing, define performance metrics. How do we measure success or failure of our products? It's not always straightforward to set acceptance criteria, but it's definitely important and something that we should talk about with our users early on, and we should make sure that we build an end-to-end prototype and encourage the team to actually test the prototype very early and frequently. I actually heard from a friend that their company decided to work on the machine learning projects, and the team told them that they have to spend 9 months just to collect data. And you certainly don't want to be in that situation where you need to spend months and months collecting data and train the model, and just to find out that it's not the right product or right solution you're looking for. So definitely try to encourage your team to test early and frequently.
Yeah, that's going to be key. Absolutely. So all this testing aspect, right? It gets back to your point about the structural changes that product managers need to have in their organization. You need to have these different disciplines, and you need to have some patience, and you also need to be able to accept that there's going to be lots of test cycles. Yeah,
exactly. And you also need to have your infrastructure ready, like what we already talked about, data collection issues. Training machine learning models often require a lot of high quality data. And we know that machine learning models outperform traditional algorithms when there are a lot of models. So it's really important to outline your data acquisition strategy from day one. Are you going to buy data, partner with other companies, gather data from your customers? Is there any privacy concern? Or can you generate data internally? And you need to think about what your competitors do as well. Do you have an advantage, comparative advantage? Can you get proprietary data against your competitors? So those are kind of things you need to think about before you start to build a machine learning product.
Mm-hmm.
And you also need a multifunctional team, as we already touched on. So it's not just machine learning engineers, it's also data scientists, software engineer, UX, UI specialist, and also communication with users is also very, very important. Like we already talked about, the performance of machine learning models improve as they are trained with more data. So it's great that these models will actually constantly improve themselves. But it also means that the performance of machine learning models will not be perfect from day one. Is that okay for your customers? And how do you define acceptance criteria in this case? If your customers need a model to perform perfectly from day one, what do you do? Do you provide a pre-trained model, or you have a backup plan? And what happens when your machine learning models actually fail to deliver the performance? Do you have a plan B? So those are kind of things you also need to think about as a product manager.
Yeah, very important. I like your point about having a patient user base as well, right? That's going to be important as well.
Yeah, sure. Yeah, and then managing user expectation, like in this case, you see Alexa and Paper. So usually we have much higher expectation for products like Pepper because it just looks more intelligent, looks more like humans. But when your technology is not able to deliver that kind of natural interaction or intelligent responses or tasks, probably better to position your products as like, for example, a smart speaker to set the right expectation.
Right. So this is where design has a big impact as well, because design can help subconsciously set user expectations.
Yeah, for sure. And another point I want to bring up is building trust. So we mentioned machine learning algorithm acts like black box, often lack transparency. So how do we help our users understand why we make this prediction, why we make this suggestion? Like this is an example from Amazon. So it shows like customers who view this item also viewed all these items below. So at least it gives you a simple one-line explanation about why they make this suggestion to you. And you can take this even further, like this is another example from Facebook. It's called Why Am I Seeing This? So you can actually click on a specific post and see why you're seeing this post, and you can even give them feedback. So it happens all the time. The machine learning model actually make the wrong prediction. In that case, how do you design a pleasant, an elegant user interface to deal with those errors and mistakes? How do you allow users to actually give you feedback so you can continue to retrain and improve your machine learning models?
Right, good point.
So,
we've got a few questions, so I think we want to get to Q&A as soon as we can.
Yeah, sure. Yeah, so we already talked about handling errors gracefully and also get user feedback. So that's really what I want to talk about today. So for machine learning models, I think the most important thing is really to recognize the difference between developing machine learning and software products. I think it's really risky to assume that because machine learning also uses codes as it's going to be the same as software products. And then really think about is there any processes or any organization aspects you would like to adjust when you're building machine learning products. And like we already talked about, it's not just a technical challenge. So it's not something that you can just hire a machine learning engineer or data scientist and expect everything to be solved immediately or magically.
Right.
So those are the things I think is most important from my experience managing machine learning products.
Fantastic. Great summary. Appreciate that. So I'm going to start the poll, and folks can answer this last question while we're doing Q&A. So let me launch this poll and get that going. But let's start addressing some of the questions. We've got a lot of great questions, Bastian. So the first one I'd like to tackle is, how do we work out, and this is from Chris S., how do we work out the ROI or benefits relative to, say, less sophisticated statistical, shallow learning, or analytics methods?
Mm-hmm. Yeah, it's an interesting question. I think ROI is probably different for different use cases or industries. So in our case, we essentially use machine learning model to enable robots to be able to automate things that humans doing. So what we can do is to firstly agree on acceptance criteria with our users or customers.
Mm-hmm.
Or we use what we call the ground truth or alternatives. What is the existing solution? What is the accuracy and performance metrics of this existing solution? And then compare that with your expected performance metrics of your machine learning model. So say, for example, right now the current accuracy of existing system is 80%, and you expect you will be able to improve your accuracy to like 90% or 95%, and you can use that to actually back calculate your ROI.
Right. Okay, that's a really good point. So if there's a big delta between what you can get from these simpler techniques to what ML can accomplish, then that may justify the ROI. That's a great point. And that's kind of related to the next question. The next question is from William N. He talks about, it's interesting that we have to accept these levels of uncertainty in the output of ML, yet it's interesting the number of attempted applications of ML at really hard problems like autonomous driving. Given the safety implications involved, what are ways to balance this uncertainty with the potential benefit in these areas that are high safety areas?
Yeah, it's a very good question. And it's actually still an ongoing research area. So I don't think anyone has a very good answer to that. A lot of the researchers are looking into, for example, transparency, explainability of machine learning models, but right now, I think it's still very difficult to say for sure if this is going to be a very safe machine learning model, because like we mentioned, machine learning is more probabilistic. It's not deterministic. So you can do all kinds of different tests. So as far as I know, for example, Waymo and a lot of self-driving car companies, they're doing all kinds of different tests. They're doing offline tests in simulation. They're also like using actual cars to do different tests in extreme scenarios. So what you can do as a product manager is try to identify as many edge cases as possible, and think about what are some like corner cases that like happens like 90%, happens like 10% of the time, 5% of the time. But being able to actually address like 100% of different use cases, I think that's very difficult. But I think because right now machine learning as a field that's evolving really, really fast, a lot of research is being done. So I'm looking forward to seeing more researchers in those areas like transparency and safety.
Yeah, that's great. Well, we had a lot of good questions, but I want to ask this last one from the list here of what practices, and this is from Virginia R., what practices need to be included to ensure non-discriminatory actions when the data may lead to discriminatory actions?
Yeah, that's also a very, very hot topic and ongoing research area as well. I think machine learning could be biased because it's learning from human data. So it's biased because the data itself is biased. So we need to start from the data. So it's important as a product manager that you actually look into those data with your data scientist, and then see, so you can design some test cases and see and use that to test and see if your machine learning model is biased. And if you can, you can also look into your data and see if the data itself is actually correctly representing what you want to predict. So I think that's also very, very important. I think maybe just one last point before we end this is that data strategy or data acquisition, data integrity is really not just the responsibility of data scientists. It's really a responsibility of all the stakeholders or even the entire company. So that as a company, the executives, stakeholders, product managers need to agree on data strategy. If you don't really have a data strategy, data scientists have no way to actually magically come up with data for good quality data for you. So that's something really we really need to think through from the beginning.
That's a really great point. So the product manager has to stay in the loop, and the product manager needs to be involved in some of this testing that you're talking about to double check these algorithms to the question to make sure bias doesn't creep in, but also in the larger picture of just having to put this whole organization together that then can holistically drive value out of machine learning without having some of these problems crop up. I think that's fantastic. Great. Well, thank you so much, Bastian. We have 1 or 2 slides that we want to just go over before people depart. So if you could advance to the next slide. I want to give folks an opportunity to see that next week we'll have an Ask Me Anything session, and I've just pasted the link into chat for that. So sign up to learn about getting ahead of digital transformation before it gets ahead of you. So sign up for that today. And then next slide, I also want you to have an opportunity to connect with Bastian, because she did a great job today filling us product managers in on both the benefits and potential perils of machine learning. So thank you so much, Bastian, for your expertise in joining us today. And folks, please connect with her online and have a great day.
Thank you so much, Roger. Thank you so much, everybody.
All right. We'll talk to you all later.